Alright, section 8.1 is on page 461, talks about using basic integration formulas. So here you're gonna kind of mix up the pot, 82, 83, 84, 85, you know, mix the order, see how much you know. And then after this chapter, we're gonna do 8.8, which has some integration, but chapter reviews, we're really gonna master this. So this section pretty much tells you where your weaknesses are. I glanced at the first problem. I noticed this problem is a match for 8.5. I'm supposed to use long division. I could take x squared divided by x squared plus 1. That's 1. X squared plus 1, subtract. So I could say this is actually the integral of 1 minus 1 over x squared plus 1 dx. And I could say that's x minus inverse tangent of x plus c. That does it. Some students have shown me another trick. Again, this is how I used to do it every time. Students said, look, if you were to glance at this, they said, look at this trick. They said, if you are to add 1 and subtract 1, that will be the integral of x squared plus 1 over x squared plus 1 minus 1 over x squared plus 1 dx. That would be the integral of 1 minus 1 over x squared plus 1. Again, this doesn't work all the time, and you follow the same steps as you did right there, and that's that. I suggest you stick with the long division unless it's that simple. Number 6, I see a radical and I recognize, wait a minute, radicals were very hard to maneuver around, and you are right. So what we need to do, we need to let u equal radical x. If I take a derivative of that, I'll get 1 over twice radical x, but I don't see that. To get a dx, I square both sides first, and then I take a derivative. And now this becomes the integral, and let me elaborate really quick. This is right there, that's my u. This is right there, that is 2u du. And I have an x left, and I know what x equal, and that is u squared minus. And now if I play with this a bit, I'll say, wait a minute, I could take a 2 out, that's u du. Isn't that, if I factor u minus 1, those cancel out? Isn't that twice natural log of u plus c? Oh, u minus 1. What was u? U was simply radical x. And there it is. So a lot of times you have to square, maybe cube, depending on the problem, and the index and the radical. 22 is next. At first glance, you might think 22 is a bit too challenging of a problem. Well, it is somewhat. If you don't see that, probably it's best to split those. So for the second part, it's really simple. That's simply natural log of absolute value of x. That's not a problem. So this is natural log of absolute value of x plus c, but I want to figure out what this is. If I look at, and I'm going to do that a bit up here, I'm going to cheat a bit first. Space, I'm going to say that's 1 over the square root of x minus 1 dx. If you recognize that I don't need a u sub because that's linear, that's like me saying x minus 1 to the negative 1/2. Add 1 to the power, divide by that. If I add 1 to the power, that is x minus 1 to the 1/2, and divide by that 2 over 1, those undo each other. So pretty much I'm looking at the square root of x minus 1 plus natural log of x plus 1 plus c. Now, if you're not seeing that, I suggest you practice a u sub. and play with that until you start seeing this. Next problem up, number 10. Now I might be thinking, wait a minute, this is partial fractions, but this doesn't factor. So what I have to do, I have to really complete the square. X squared minus 2x, half of the middle number squared is 1. Doesn't that mean plus 1? Or minus 1 plus 2, whatever you like. Wouldn't that be x minus 1 squared plus 1? Now, I don't know how comfortable you are with this. Kind of run into each other. Let me just make more space. Here we go. So, I know this is 8. Inverse tangent of x minus 1 evaluated from 1 to 2. This is 8 and 2. And if you'd like to use a u sub right there, you can go ahead. U equal x minus 1 and proceed. That's going to be inverse tangent of 1 minus inverse tangent of 0. And the inverse tangent of 1 is pi over 4 minus 0. So that is 2 pi. There. That takes care of that problem. So this is really where you're going to practice and figure out where you need help with, and go to that section and do more of these problems. Here's another problem. Well, this one I know what to do. I'm going to let, if I let u equal this, du wouldn't work. So to get rid of a radical, I'm going to say, I'm going to let t equal, what do you square to get 3? Radical 3 tan of theta, if you remember, from section 8.4. And dt is radical 3 secant squared of theta d theta. This is going to become the integral of, and let's see, dt is right there, radical 3 secant squared of theta d theta. The denominator, t, is right there, that's radical 3 tan of theta. And the radical right there, that's the square root of 3 plus, and if I square this, wouldn't that be 3 tan squared of theta? So this radical part, if I factor a 3 out, 1 plus tangent squared of theta, square root of 3 secant squared of theta. So this is the integral of radical 3 secant squared of theta d theta divided by radical 3 tan of theta times radical 3 secant of theta. So one of those cancel out, and one of those cancel out. And that's going to be 1 over radical 3, the integral. And if I write this, move this up, that's the cotangent. Cotangent is really the cotangent, cosine of theta over sine of theta. And secant is 1 over cosine of theta. So those cancel out. And I would be left with 1 over radical 3, the integral of, and that's the cosecant of theta d theta. That is 1 over radical 3. We said that's going to be natural log of the cosecant of theta minus the cotan of theta plus c. And that's going to be 1 over radical 3 natural log. And I have to go back to theta. I can't leave my answer in theta. I mean, I have to go back to x, in this case t, and there's the connection. If you draw the triangle, you're saying t over radical 3 equal tan of theta, and that is the opposite over the adjacent. The opposite of theta is t, adjacent is radical 3, and that makes this the square root of t plus 3 squared. So I want the cosecant, which is the hypotenuse, over the opposite, minus the cotangent, which is the adjacent over the opposite. And that would be my answer. (32) has a small trick. I look at number 32 and I notice that, you know what, nothing works. This doesn't match anything. I'm tempted to say let x equal tan of theta, but then do you see how that's going to be an inverse? That's a problem. But I notice this is from negative a to a. And I notice that if I throw a minus n square root of 1 plus negative x squared, the sine of negative x. That is square root of 1 plus x squared times negative the sine of x. That's negative the square root of 1 plus x squared, the sine of x, which means this is an odd function. And if you recall from calculus, the integral from negative a to a of f of x dx equal 0 if f of x is odd, and it equals twice the integral from 0 to a of f of x dx if f of x is even, and since this is odd, we say that's 0. That's not normally a good test question, but I thought I'll point that out. 38 is next. I look at this problem and nothing works. Anytime you're stuck with a radical, you could try something. I didn't try it already. I should have tried that there. You could try a conjugate. Like here, you could try the conjugate, see if that works. And with trig functions, the same deal. You could try the conjugate. Cosine of theta plus 1 over cosine of theta plus 1. That is the integral of cosine of theta plus 1 d theta over cosine squared of theta minus 1. That is the integral of the cosine of theta plus 1 over, and that is negative sine squared of theta d theta. And that is negative the integral of cosine of theta over sine squared of theta d theta. Take the negative up front, plus the integral of cosecant squared of theta d theta. That would be here. I'm going to split those up. Negative, if I let u equal sine of theta, du is cosine of theta d theta. So this is the integral of u squared du, nothing more. And here, I say minus. This is going to be the integral of, and let's see, take a derivative of negative cotangent, right? So that is negative cotangent of theta. There. So this is going to equal negative. This is u to the negative 2. Add 1 to the power, divide by that. And that's going to be a positive 1 over u, and u is a sine. So the final answer is cosecant of theta plus cotan of theta